topic, nanoparticles for finger mark detection. And in our previous presentation, we already know something about nanoparticles. So let's move on to the finger mark. The finger mark that we wanted to detect is called a latent finger mark. Latent finger mark means a certain kind of finger mark that you can see at the first time, but after some particular steps, the finger mark will appear. And by those kind of steps, we call detecting the latent finger mark. And the most common way to detecting the finger mark is using a carbon powder or silver powder to detecting the moisture in the finger mark. So you might see police using a brush and brushing everywhere. They are actually detecting the latent finger mark. And in our experiment, we want to use a nano gold to replace the powder. Next, this is what we got. If the nano gold will reaction with our fatty in our sweat, because our fatty will transfer the gold ion to a nano gold, and it will combine the nano gold on the surface of the finger mark at the same time. So if we put a finger mark into a nano gold solution by maybe 1 or 2 hours, and it will go like this. But here comes some problem. As you can see, the nano gold is red. So if the surface that the finger mark on is red already, or the color is too complicated, it will make the finger mark difficult to be seen. And to make our experiment more obviously, we want to use a nano cluster to replace the nano gold. So let's see what is a nano cluster. Nano cluster is actually a kind of nano gold, but it is more small than the normal gold particle. So a nano cluster is actually the small, tiny thing about nano gold. And a nano cluster consists about 20 atoms of a gold atom. And its diameter is smaller than 2 nanometers. Most of the properties is the same as a normal nanoparticle, but here comes the biggest difference. The nanocluster is fluorescent. So if we use a nanocluster to detecting the finger mark, we might get a fluorescent finger mark. And let's see our experiment. First, we put our finger mark on the paper, actually my finger mark, and then we dip the paper into a 3 different kind of gold solution for 1 hour. And then we put the paper under a UV light. And this is what we got. From left to right, we put the paper into a nanoparticle solution, nanocluster solution, and tetrachloric solution. Tetrachloric solution in Chinese is named 四氯氰酸. It's a kind of solution that contains a lot of gold ion. And after 1 hour, as you can see, if we put the finger mark into a nanoparticle or nanocluster solution, it will come a fluorescent finger mark in the middle of the paper. So we know that the nano gold can detecting the latent finger mark. To progress our experiment, we think maybe we can make another kind of nano gold that will reaction with a certain kind of material. By doing this, we can detecting the latent finger mark that contains that kind of material. So if the finger mark was not contain the material we wanted to detect, it will not be detecting. And if we want to do this, we need to conjugate the antibody or protein. In the previous presentation, we already know something about conjugation, and we know that we can conjugate the antibody or protein on the surface of the nano gold. So it's the same. We can conjugate the antibody and protein on the surface of the nanocluster too. So if we conjugate the antibody, they will only react with maybe ketamine. Then the latent finger mark that contains ketamine will be detected. And this is our experiment. First, we put PSA and gold ion together and to make the nanocluster. And then we put antibody with the IgG links, and we put EDC and NHS into the nanogold solution. After a series of reactions, we can conjugate the antibody on the surface of the nanocluster. And then, to make sure our experiment was a success, we drip some ketamine in the middle of the paper, then we drip the paper, we stick the paper into a gold solution. And this is our result. As you can see, the middle part that without any fluorescent reaction is actually where we drip the ketamine. So we find that our nanogold is actually won't react with the ketamine. So our conjugation was failed. So we get back to our experiment and we found that if we want to make a nanocluster, the area requires pH 10. But in this part of the reaction, it requires pH 4. So the next step we do is to figure out how actually can the nanocluster exist. And we found that at pH 5 to 6, the surface of the nanocluster, which is the BSA, it will be destroyed by the acid. So our next experiment, we maintain the pH at 7. And we separate this experiment into 4 parts. In the first and the second part, we didn't conjugate the antibody. And for the third and fourth one, we conjugate the antibody. For the third part of the experiment was drip on the paper that without ketamine. And this is our result. As you can see, if we didn't conjugate any antibody, then the nanocluster will not reaction with the ketamine, and it will not any fluorescent reaction. But for the third and the fourth one, we both got the fluorescent reaction. So to make our experiment more specific, we want to use another way to combine nanoparticle and nanocluster. The reason we do this is because when we were searching the information, we found many papers about conjugating a nanoparticle, but only a few is talking about conjugating a nanocluster. So we think if we combine the nanoparticle and nanocluster together, it will make our experiment more easily to be successful. So this is what we do. First, we conjugate the antibody on the surface of the nanoparticle, and then we use nanocluster to cover the surface of the nanoparticle. And as I said, we want to make sure our experiment was a success. By doing this, we change our solvent of the solution from water to PBST. PBST is a kind of solution that contains negative charge. So if the nanoparticle was not covered by nanocluster or BSA, then the nanoparticle will gather together and change to look like the left pipe in the picture. The color will be changed to black. And if the nanoparticle was covered by BSA, not nanocluster, it won't have any fluorescent reaction, just like the right pipe in the picture. So the middle one is what we got in this experiment. And next step, we want to make sure our nanogold will only react with a ketamine. So we do our last experiment again, and we found that the only paper that contains nanoparticle and antibody and ketamine will have a red step in the middle of the paper, which means our experiment was finally success. And next, this is all for our experiment. And I want to thank to some people. And for this part, I want to use Chinese. 我要感谢的是台北市中文讲座计划来辅助我们的实验，然后谢谢教授助教，他常指点我们的研究方向，让我们实验可以成功。然后还要感谢我们实验室的休息室里面有很多的食物可以吃，然后助教都吃不完，所以我们每次去的时候都有很多食物可以吃。那当然我们要感谢我们的家长。因为我们做实验的时候，其实不要看我们实验非常轻松，看起来好像很简单一样。其实我们常常做到晚上10点才能回家。那这个时候呢，家长其实都在家里等着我们回家，然后守护着我们。所以非常感谢家长来一直支持我们做实验。那最后呢，也要感谢在座聆听的各位。
谢谢大家。